Sorry about all the fan noise, you guys. It's 105 degrees up here today. Air conditioning for the house isn't even keeping up. It's unbelievable. It's cool out here in the shop because I got like 22 inches of insulation all the way around here, and I got the dogs out here with me. So if you hear them scuffling around, yeah, I apologize. Mr. C, I refilled your 8 pill here, and when I go to key it, I was seeing this weird thing happen. So we'll say this is the watt meter and it's on 0, right? And I go to key it and it was going. It'd rise real slow to the dead key, then you'd unkey it. You key it up again, it'd rise up real slow, and then unkey it. And I go to modulate and I'm back. Hello. And I'm like, why isn't it consistent, right? And you get about 2-3 keys into it, and all of a sudden it starts going. Even on the average meter, it was moving really slow. Okay. So that told me that something was in the process of breaking down, or something had broke down and was tuned to operate when it was hot, which is not what you want. So I started digging. Now, I'm here to tell you, this amp got sent up to me because the guy ran it on about 17 volts and it come apart on him. So I knew I was going to go into a pre-volted box, but we did break the seal on it. So the parts that were in here were what were in here when it was made. So I started digging, and over the top of the output transformers are these little bastards. And I know you probably can't read that. That's a 102P, which is 1000 picofarad, 3 kVA, and it's a disc capacitor. It's fairly thick. So I started looking at it on a FLIR, and you go to key up, and them son of bitches just get hot. Started radiating heat. But once they got up over about 100 degrees, all of a sudden the watt started working the way it was supposed to. It started swinging. Hello, audio. Hello, audio. Hello, audio. You let it sit for 2 or 3 minutes, let the box fully cool off. You go to key up and you go, hello. You unkey it again, and hello. And key it again, hello. And then it started heating up again, then you start working again. These are metal clad, long leg, silver dip capacitors. Okay, you see these? These here recently, this is one from Charger, has become very rare. These things are getting really hard to find. So there's guys that are mass producing that are trying to find any way around this that they can. Now the ones that everybody loves are the Semcos. They look like this. That guy got a green label on them. Oh, focus. Made by Semco. Virtually the same part. One was manufactured by a guy here in the United States trying to make it happen for all of us, which we're grateful for. But we're having a hard time keeping those supplied. So there's guys out there that are struggling right now to make it happen. One of the solutions they came up with is this. Now, when I hook this up, I know this is a cheapy capacitance meter, but it doesn't have to be high dollar. Just has to read the value. When I go to hook this up, we can clearly see it's reading 1490 and counting up. That should read about 1000. So let's do a little experiment here. I'm going to grab our hot air torch. We're going to start heating up the cap. Down it goes. 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 And on down we go. We're at 460, 430. Remember, we're shooting for 1,000 puff, right? 380, 365. Now what happens is the air is going to start cooling this part off. Okay? And the capacitance is going to keep coming back up. And up we come, and up we come. And up we come. I'm not a big fan of this. That's why I went in and I'm doing this video. I changed some parts inside your box. Now if we could get this capacitance to stay at 1,000, like right about anywhere from here to about here is tunable. But as this part cools off, it's going to keep gaining in capacitance. All of these little yellow disc capacitors are the same way. It's the same thing. 1485. Remember, it's supposed to be 1,000 according to what it's labeled at. So we'll start heating it up. Heat it up a little bit. Heat up a little bit. Okay, now people are going to say that, well, BBI, that's not fair. That's not fair. You're making it extremely hot. Okay, well, here we'll give you a fair comparison. Yeah, it's so hot I can't even hold it in my hands. Wait a minute, I can. This is only heating it by maybe 30 or 40 degrees. 50 degrees, and it's coming apart in its capacitance value. Let's see here, I gotta prop that up somehow. I'll grab this. Used to use this. I bought this at Radio Shack when I was a kid. I used to use it to wire microphones. Okay, so we're at 1,008. That thing's 400 degrees, I bet you. If I grabbed that son of a bitch and I held onto it with my fingers right now, I'd burn myself. It's 91 degrees. Let's get it hot. Remember, silver clad, anything silver gives you a false temperature reading. There's 100, here. Take it up to 190 degrees. And it dissipates the heat quicker. Rock solid. That's the reason everybody's looking for these. And I understand, fucking son of a bitch. Really, Luke? You just got done bragging to everybody. Oh, it's so hot, it's so hot. Dumbass. Everybody's struggling to find a replacement right now. So let's do this same test again. Use the old Ryobi drill to prop it up on here for camera's sake. So we're at 1,500 degrees. Our baseline temperature is 85, 78 degrees. $78 degrees. It's 84 degrees, and our capacitance on the meter is already dropping. 83 degrees. 104 degrees. 104 degrees. It gets hotter than that in your car, and it's already down to 700. 120, and it's down to 400 degrees, or 400 puff. I can prove my point. I don't know if it's the voltage that damaged it, or is it this is an acceptable thing now. I don't know. I know that you can get away with using other devices. It's like a solution is on the horizon. Like we're doing SMAs now. And we're doing a thing where you're putting the SMA on a board and coming off the back side of the, coming up off the transformer. So now what I did for you, Mr. C, is I just went in and I had some metal clads. And I used the old reliable metal clads, and I replaced the disc capacitors that were here with actual metal clads. But if you take a board and lay it across the top of the transformer and put the SMA back up here, you're playing the induction rule, and it takes a lot more of the heat off the component. A lot more heat off the component, but it is what it is. Good Lord, I hope we can find another supply of these. Anyhow, I'll be back. Okay, Mr. C. I'm going to send this bag of PP100s back. There's 7 good ones in here and 1 bad one. I'm going to send back your little disc capacitors that were in there. I'm going to throw them in this bag for you. Anywho, we went in here and we put the latest and greatest HGs in here. Now, Mr. C is going to try and volt this box, and my suggestion to him is to volt it to about 15.5 volts and leave it alone and let it run. We're going to use the RSP 3000-1200 200 amp supply, which we've modified a little bit. We're going to run at 14.5, and we're going to see what this thing does. We're going to hit it first with the Connex 4400. Actually, I need to take this mic off out of that, plug it into that one there. Okay, so we're going to hit it with the Connex first, and then we're going to come back, we're going to hit it with a 2950 with a 2-pill. Now, Mr. C, as you go up, you have to decrease your drive. So as you go up in voltage, you have to decrease your drive, because remember, the HGs are a little bit more sensitive than the Toshibas. So if you try to dump like 300 watts of drive in this thing on 17 volts, it's going to come apart on you in a New York second. It just is what it is. The HGs are a decent option over the Toshiba. The Toshiba is still a better component in my opinion. It puts up with higher volts and more drive, but we're getting the same amount of power out of them, tit for tat. So let's run around the band here real quick. We've got a 1000 watt slug in PEP and 2X, so fully deflected it's 2000 watts. 1000 watt slug in average, 5 watt slug in reverse. We're going to use a 2-pill, the Connex, a 2950, 5 watt slug there, 5 watt slug there, and we're going to use the RSP 3000. So let's get on with it. Let me go down here and we'll plug in the RSP 3000. .5 or 5.9. Okay. So we got the amp off at the moment. I'm going to show you input drive. About 100 watts, about 120 actually. It's about 50 bird. Remember, 2x face value, average peak power. About 650 bird, 620 bird. About 1900 out of the box. So only 120 watts of drive. That's on 14.3 volts. Like I said, Mr. C, I strongly suggest that you don't go above 15.5 at the most. I can't guarantee anything about that. So 120 watts of drive. Hello. We just tripped the power supply. Look at that. Let me reset. We'll be right back. Just give me a second. I'm having all kinds of problems over here because of the heat. line voltage and all kinds of stuff. If I hook up my big supply, it's popping the breaker in a panel. It's just hot. Everybody's running their air conditioning to the max. It's 105 degrees in the shade now. The rest of the country that's been experiencing like 115s, 120s, it ain't nothing. But for out here, 105's hot. So anywho, now that's with 120 watts of drive. So let's go ahead and we're going to disconnect the Connex. We're going to disconnect the Connex. We're going to hook up a bench 2 pill. Whoop. I'm going to show you input tune. Let's take the microphone off of here. Stick it up here. Turn the Connex off. About 200, 225 watts of drive. Let me show you the input tune into the box. 2950, 5 watt slug. Between the 2950 and the amplifier. Of course, the 2 pills in the way. Audio. Audio. Look at the kind of power response we're getting out of this with only 20 watts of drive. That's no joke. Turn the amp off. Audio. 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 Put about 7-8 bird into it. Only 20 watts of drive. Audio. I mean, we're seeing 380 bird out of it. Audio. About 1100 with 20 watts of drive, right? On 14 volts. So let's kick on the 2 pill. We're tickling the 800 bird mark, and we're seeing well over 2,000 peak power out of it. Well, it just showed me 900 bird. 980 bird. Let's see if we can get it to do it again. So we're seeing constant peaks over 800 bird out of this little guy. It's screaming. Now, I took the PP100s out and I put the HGs in. And I had to change the input tune. I had to add some capacitance on the input. I had to take capacitance out of the output. This tube was all the way out here. I had to move it in quite a bit. When I did that, it stepped right up. Well, anyhow, that's it, man. It's freaking hot. I'm going in the house. I might stay out here, I don't know. It's freaking hot. I'm calling it. Mr. C, here's your 8 pill. All done, ready to go, kicking ass, taking names. So on that note, I'm going to wrap this Dog and Pony show up, put the lid on it, and get it ready for it to come home. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram, all over the webbage. Gentlemen, I appreciate your all support. I got to get on to the next project. I got a bunch of new stuff coming out. I got the 48 pill almost done for Paul. I got to build the 2x8 base unit that's going to be its driver. Then I got a bunch of MOSFET boxes getting ready to come out. I've already started on the MOSFET boxes in the background to just try and get those things clicked out as quick as I can. Anyhow, guys, I gotta go. It's hot. Freaking hot. Hot, hot. I'll see you guys.